Okay. Can everyone hear me okay? You good? Yeah. Okay. Thank you very much for taking time to come and see my talk. Hopefully you'll find some tips in here that you can take back to the project and get faster feedback. So I'm going to do a little bit of history about where this talk came from. I sent an email to a mailing list I'm a member of, and a lot of people reacted in a very positive, stunned, disbelieving way. And basically, you had to talk about this. You had to blog about it. And this was my blog before I said anything that anybody cared about. And then this was the day that I blogged about fast build times. So there was quite a reaction. And within 7 days of writing that blog, I was talking at a conference about the blog post, about the email. So everything kind of happened within about 10 days period of kind of just mentioning something. So that's really kind of where this talk came from. It just came from an email message that kind of went onto a blog post and into a talk. So the next thing, and you've heard this already from a few speakers, is don't listen to a word I say. So everything I'm going to give you, obviously, has worked for me. It's expert advice, but what I really want you to do is I want you to go back to your project and challenge the way you do things. So that's the real benefit. Now I'm going to give you some very concrete tips of things that I've done. Does that mean you can just blindly apply them? Of course not. But some of you still are going to just do that, and then you're going to be cursing me and sending me rude tweets. So I want you to measure and try and do this scientifically. Work out how long your build is taking. Where is the time in your build? And it's the most important step. Is just work it out. Where are you spending all this time? And be ruthless. Don't every single library, every single tool. I've changed operating system because of Steve. So just be as ruthless as you can be to get the feedback loop that you need to deliver your software. So why do I think we've kind of got where we are? Well, this is a picture of a frog being boiled alive. I don't know, in English there's a saying, I don't know if it applies, but basically that you can cook a frog. If you cook it slowly, you won't notice, it'll just sit there. And I kind of feel like this is what we've done in the software industry. We've gone, my build is 10 minutes. My build is half an hour. My build is a week, 3 weeks, a year, and it's statement. There's no challenging of it. You get welcomed onto a new project, and they say, welcome, have a coffee, the build's running, we'll be back soon. And that's just the way it is. So I kind of had a little look at where did this come from. So in 1999, Ken Beck actually put it in his book when he was talking about what they'd done in their XP team. And he basically said, any shorter than 10 minutes, and I can't have a coffee. So everybody says, 10 minutes, that's the target build time. We could not possibly do any better than that. It's kind of, that's the de facto. So I kind of think 1999, our PC's a little bit faster than they were then. Maybe we've got a little bit better at writing code, maybe we can go a bit faster. So for me, it kind of seemed fitting to talk about a 10-second build. So the next question people always ask me is, surely this will only work on greenfield or new projects. So I've been working at a client, and we have some quite old applications. So the top one is 5 years old. It's actually 6 years old now. This slide needs updating. Probably 160,000 lines of code. This is including everything. So I'm counting. It's a Java application. I'm counting Java, SQL. All of the code is in there. So when I joined the team, it had a 45-minute build time, which was perceived as not too bad for a 5-6-year-old application. Since then, I've got it down to about 2 minutes 20 at the moment. I'm struggling getting it below the 2 minutes mark, but it is a pretty big old app, and we've been kind of chopping it up. So, that's just a fluke, that's just one off. The next one is we took a 3-year-old app with 92,000 lines of code, went from 20 to 3. So again, actually that's gone down now, that's just gone under 2 minutes, so we're kind of happy about that. And then this is the flip side. So if you take some of the tips I'm going to give you today, you can go the other way when you're starting. If you are lucky enough to start a new project, you can start with the kind of right intentions. So we've got now this 15,000 line application, line 3 here, and it's running at 12 seconds. So this talk was actually triggered by these 2 builds here, because they've gone over my kind of 10-second mark, and I started to get a bit anxious about them. So, and what happens is, the build time goes up, we've added new functionality, it's inevitable, and then I'll spend a day looking and profiling it and working out what it is, and then we can bring it back down again. So it's a continual thing. It's not something you do and then you forget about, because you just get back to where we started. Okay, so I think the main strategy everyone tells you to do for sorting out your build time is to split your build. First thing you do, your build's getting slow, you say, here's my fast tests, and here's my slow tests. And I'll split them in 2. Maybe one of them I call unit tests, and maybe one of them is my end-to-end exception test. Doesn't really matter how you skin it, but the point is, for me, I don't think you've said fast tests and slow tests. I think you've said tests I care about, tests I don't care about. And I think the reality is you just forget about those long ones. And you wait until another team comes and says to you, you broke the build in the long test suite. Can you fix it? It's been broken for 3 days. And you're like, oh, it really was broken. It wasn't just an intermittent break. So I think there's a problem there. We just say the only way of fixing this is to split it that way. Or another way is to execute the test in parallel. Now, I'm not saying that isn't a good thing to do, and I actually do that as well, but for me that's just a tactical fix. You've just made all your tests run in parallel, and that can be a challenge in itself, but you haven't actually listened to your system. So when I talk about divide and conquer, I actually think the primary thing that your build is telling you is if your build gets too big, you should split up your application into smaller parts, into libraries, into components. Now, I'm not saying this is the only reason to do it, it's just this is another feedback mechanism that is telling you that your application has grown too big. So it's just another thing on your list. It's not the reason, if you say, Dan said split the app because the build's too long, that's not really going to wash it, is it? You split the app because of many reasons, and this is just another feedback loop. So it's a bit like when we started doing TDD, we didn't change our production code when we started. We said, no, I'm going to test shouldn't change my production code, and then we realized actually it was trying to make us decouple our system. It's the same thing. When your build is slow, your build is trying to tell you you need to break up your app into more testable sizes of components. So that's the main message. When I talk about divide and conquer, I look at the system and say, could I extract a library here? Could I extract another application? And actually, if I just go back one, if I just go back one to these examples, these 3 applications have actually been broken out of the top 2. So they have been pulled out. And when we've done that, when I pulled out one of them, I swapped, in this project here, I swapped 20 minutes for 12 seconds because I was able to extract the functionality, and because I'm testing at a library level, my acceptance test is an API call, not an HTTP call or a JMS call, a messaging call. So by pulling something out, suddenly my contract, my end-to-end acceptance for that component was suddenly the direct method call. So suddenly there's a different, you get to swap a bunch of tests. What other techniques are there? So obviously, we're talking a lot, we're in it's an Agile conference, we're talking about testing and feedback. So there's some tricks we can do at the testing level. And I think probably the most important one, and this goes on to not ending up with a spaghetti code base and ending up with a massive brittle suite of tests that are kind of like a noose around your neck, is to make your test be written in your programming language of choice. And ideally a programming language which has refactoring support. So I'm not saying it has to be strong title, dynamic, whatever, but just you've got good tool support for that testing framework, and you can refactor your tests. When the suite gets too big, you get too many tests, or there's too much duplication in them, you can split them up and modularize them. You should be using the same technique you use on your production code, on your test code. So as soon as you start moving away, so at my organisation, previously they were writing everything in Fitness and Concordia, which are HTML-based testing frameworks. So you write a test fixture, and then you write some plumbing behind it, and it works, it's great, and the users love it because they get a nice little table. But the problem is you've now got this thing that's unmaintainable. So I'm coming onto projects at 5-6 years old, and we had literally about 5,000 Concordian tests, and the duplication in those tests, because people just copy and paste a table from one test to another one, it just spread. And this whole thing kind of started as I had a bug fix that I had to change, and it took me one day to fix the production code, and it took me 2 weeks to fix all of the duplicated tests, because it was just the same value copied across. So the first thing I did there is I rewrote those tests in Java. It was a Java project, and then we generated HTML documentation from the tests, so we flipped the model on its head. So that was a really big win, because now I can refactor my tests. Now if I can refactor my tests, that means I can make my tests quicker, because they're Java code, and I can use all my profiling tools, all of my my tool suite. And I'm not spending time with parsing HTML. Fitness and Concordia, they've got parsers, but they're not industry designed to be super fast. They're designed to just get the job done. It's not like the Java compiler that's had millions of pounds spent in making it super fast. It's just designed to parse some HTML and execute some tests. So that's one thing, refactoring, and then I think and these kind of three things here all come together, which is a concept that I call a contract test. And what this is if you have a dependency, any external dependency, a database, even your web application, I actually consider the web application you sit in to be an external dependency, or it's an integration point. It's probably a better way of looking at it. So your application has an integration with the hosted container, even if it's JMS or if it is a web application. And what you can do is you can actually decouple yourself from that and write a suite of tests, and I call them a contract test. And what this contract test does is you put in each implementation. So let's talk about a simple example rather than a web server. Let's talk about a database. So you have a database that you integrate to, and you have a really good, you followed maybe DDD, you've created a repository or some data abstraction layer, and you've implemented that, and you've got your test for that, and that says, I can put in a user into the user repository, I can get one out, I can change his password, or whatever. And what you do with a contract test is you write a production quality in-memory version. So some people just call this a normal start, but I actually think it goes further than that. It has to be production quality. It has to support all of the same features that your production one does. So you do in memory, but if you say find a user by his last name, Vader, then it'll go search for it and find it. So that's really important that you make it production quality. So it means you can swap it in and out. It also means that in every test, you don't have to create a new stub or a new mock. You can just use one that you've already written and it works in the same way. So this allows you in your tests to choose which implementation you want to use. And you do not need to recheck the login on every single test. You don't need to go in a workflow, add a user called admin with a special password, logs in, and then I go to the page I'm really testing and do something. You can skip that bit. Now you obviously want to have a test that tests that part, but you don't need to have 2,000 tests doing the same workflow. So again, that gives you choices, because what you can do is all those other tests you can just say, I'll use an in-memory version, and B, I'll go straight to the user is logged in and skip the login bit. So again, you can restructure a test and make them much shorter. Now obviously these things all sound really obvious, but they're all little pieces that kind of build up together to enable you to get your build really quick. So that's really the core concepts you can do in testing. What are the other areas? Well, if you just did the testing side, that'd be good. But again, I don't think you've listened to your build. Your build is slow. Do you actually know why it's slow? So I talked about some of the testing tools there passing and taking a long time. I bet you most people here who, actually maybe all the people in this room do care because you're in this room listening to me, so maybe you do know exactly where the time is spent. But I think you'd be shocked at some of the libraries. So at my current client, so we've got these new projects that I've created that have like 10, 20-second builds, some down to like 5 seconds. And one of the other teams, they came over to me and said, Dan, you're talking utter rubbish because I've got a single test, and that one test, it takes 14 seconds just to start the test. I haven't even got my app up yet. I haven't even done the thing under test. And I was like, well, what's taking 14 seconds? And so we sat down together and we measured it. And this again was a legacy application. So he had 5 years worth of XML Spring App config in this app. So a good old application. And it was taking 14 seconds to pass that XML. We haven't even used anything yet. And so we kind of looked around and we found this thing you can do default lazy init. And the Spring documentation says don't use this because it lazily initializes your application. You won't know about runtime errors. But you're running a test, so you're going to know about a runtime error. So this means it will only start up things that your test actually uses. And so we did that, and it suddenly went from 14 seconds to 1 second. And that was on every test. And this team, what they'd previously done is they just parallelized their build and just said, we'll run everything in separate JVMs. We'll shard up our whole app, and we'll just run all the tests in parallel. And they've gone from a 2-hour build to a 20-minute build, which is good. I'm not taking it away. But I was like, you still haven't actually fixed anything. You haven't changed your production code at all. You haven't actually worked out why it's taking so long to do everything. So then once we started talking, we started going through and looking and analysing each one. And in each case, it was fairly easy to actually find out what the root cause is and work out a way around it. So I'm just going to give some other quick examples. So actually annotations are better. You can see they're about 10 times better, 1.3 seconds. But that's still a long, long time. For me, I can't afford 1.3 seconds. Normally most of my tests, the whole suite finishes in about 3-4 seconds, so I can't have a single test taking 1.3. Hibernate, we were using the HVM file, not the annotation, and it was a tiny project. It was not tiny, it was 90,000 lines of code, and we're taking 1.3 seconds to process a 200-line XML file, which I was just like, how can you possibly be that slow to process an XML file? If you know about this, if you know where the time is spent, then maybe you can look at different things. So either caching this result, or switching it to using annotations if that's faster, or switching to a different library. So GWT was very popular for a while. Everyone was going GWT mad. We had GWT on one of our projects. It was taking 30 seconds just to compile the Java to JavaScript. It wasn't even running anything. And because of that, our whole app was JavaScript based. We had to run full Selenium builds for everything, and the Selenium builds were taking 20 minutes to run on our app. We actually replaced GWT with just a classic MVC framework. We went from 4.6 thousand lines of JavaScript to 20 lines of JavaScript because we realized the app really didn't need, so this is an enterprise application, we didn't need lots of whizzy-bang things. There was just a few autocomplete forms that were looking up data. So we were able to just get it down to a simple MVC app. There was no JavaScript, there was no extra compiling, so we got rid of 30 seconds to compile. But also, because we only had 20 lines of JavaScript, we just wrote a JavaScript unit test for that JavaScript. And then our end-to-end test switched to using HTML unit, and it went from 20 minutes to 3 minutes. And that was just with one library replacement. It took us 2 weeks to rip out GWT and replace it with an MVC framework. And every time we do it, the build was getting faster. We were going, wow, this is awesome. Every time you ran a test before, GWT used to recompile all the classes. It was really slow. And now all of our tests suddenly just run instantly. And everyone was, you could see the energy in the room as everyone was going, getting faster and faster. And there was a Lucene bug that they fixed. I don't know if anyone uses Lucene, but basically they fixed the bug that we noticed in one version switching to another. So we actually ended up extending Lucene and making it so we could turn that bug on and off, because for us it was a feature, go really fast mode. So those are some of the things we've seen. Now this is the more interesting one. How many people in the audience you do web apps by day? Okay, that's good. How many people in the Java space? Is there a good Java space here? Okay, .NET? Okay, cool. Alright, so there's good. So this, I'm talking about JVM ones here. I'm sorry, I'm quite Java specific. It's whichever my current clients is paying me to work on is whatever I currently focus on. So we deploy, at my client, we deploy into Tomcat. And I'm going to be very generous here and say that Tomcat takes 2 seconds to start up. That basically is a lie, but I like to be nice. That's an empty Tomcat, take 2 seconds to start up. If you put an app in it, now it's much slower. So first thing we did on our team, we were like 2 seconds every test. No, we're not going to do that. And also, most people, what they do is they just deploy their app once at the beginning, run all their tests, and then take it back down. I didn't want to do that. My goal was clean test. Every single test will bring out the whole app, run everything, tear it all back down, empty database, empty everything. And that's my goal, and that's actually where I got to. So first thing we did is we switched to Jetty, and so in Jetty we had about 2 seconds to deploy again when you're doing a full deploy, and then we did very similar to what you saw earlier today. So we actually did Jetty in code, and then we went down to 1 second by doing it in code. 1 second startup, that's not fast enough. I want to get it faster. So then I found out the reason why it's taking 1 second is for Jetty to release the socket port, it would take about it would actually do a time wait to release it, which is just crazy. So I worked out if I just did it on a dynamic port, so port 0, then it would always get a fresh one and it won't wait. And now we're down to 30 milliseconds, but it's still not fast enough. So then, obviously, so cold and warm, that means cold is if a brand new JVM, 30 milliseconds, warm is for each test. So each test, now I'm down to 3 milliseconds. Yeah, it's good, but I'm still not done. Then I knew that in Java 6 they released an embedded server. So in Java 6 and in .NET, so .NET's got an embedded one as well, so you don't have to use ASP.NET, you can use the embedded server. And they've got much faster startup because they don't have any of the extra stuff, you know, all the enterprise features, but actually for probably your tests, you know, what you probably need is the server API or the you know, ASP.NET HTTP handler interface. You know, you can go to the metal and actually get it really quick. So that was good. Cold VM, 20 milliseconds. Warm, 1 millisecond. And I thought I was done, but that's still not fast enough. 1 millisecond is too long and anything. So what do I actually do? So I have tests that use the full one, but I actually have an in-memory version that I actually use. So this has 0 millisecond startup because it has no sockets to open, no nothing. But it implements exactly the same contract as all of these. So I have support for these. I've created an interface, an HTTP interface, that takes a request and returns a response. You know, everyone understands that, everyone understands HTTP. And you can create one too. And then you can decouple yourself from any of your containers. And then basically you can run completely in memory. And as long as you make sure your interface absolutely embodies what an HTTP message is, which is ultimately some bytes or a string. You know, if you don't have to do binary data, you can just have an HTTP message as a string. And now suddenly, you're completely decoupled from the outside world, but you know that your contract, so this is all covered by a contract test, so I check that my in-memory one behaves in the same quirky way as the real one. So for example, Tomcat lowercases HTTP headers, just to you know, kind of you know, send you, screw you up a little bit as you go through. So this is what it's all about. So you can just keep on abstracting yourself away and get to the point where you can run your test with whichever implementation you want to do. And this is what, to give confidence, when you're first starting this, I highly recommend you run parallel builds. So you can have a local super fast build on your machine, and you can have on the CI server, you can have that local super fast build run, and at the same time kick off one with the full, say, you know, production stack, WebSphere, Tomcat, you know, Oracle server, whatever your enterprise requires you to integrate with. And what you do with that is that you're A, running those whole suites in parallel, but B, it's very crystal clear that if one fails and the other one passes, it's not like the slow and fast test. If you do the slow and fast, what you said is these tests I don't care about. When you're running the same tests with just different integration points, when you have a failure, you know what's different. The only thing that's different is your integration point. So you've got an integration failure. So when the test failed, it is telling you you've got an integration failure, not that it's flaky. So that's a really important, kind of difference to understand that. I hope that makes sense. Like I said, I went on a bit of a journey. I was a .NET programmer, then I became a Java programmer, then I did quite a lot of Scala work, and I rewrote all my libraries in Scala, ported them from Java. I ported ones from .NET to Scala, and basically I had a whole suite of stuff going on. And then one day I realised, I was like, oh, my libraries, they're taking a long time to run a build on them. And these are not big projects. These are 20,000 lines of code, open source projects. And my build's up to a minute, and I'm like, where does a minute come from? These are stuff that I've grown and coded, and this goes back to measuring. So I measured it, and some people had said to me, well, the Scala compiler, it's a bit slow, but I obviously had too much time on my hands, so I took my project. And I noticed that I do a clean build by default on my CI server. And I might do incremental locally, but mainly I do clean all the time, to be honest. And my build was taking 56 seconds. So these are seconds down here, and these are different tools and languages. So my build was taking 56 seconds. And I was like, this is mad. And I was using SVT, which is like the cool kid tool. And with incremental compile with SVT, it was about 6-7 seconds. So I was like, yeah, it's good. It's really good. But when I check in, my build server would run it clean. So in 56 seconds, I'd have to wait. I'm sitting there going, come on. I want to get my feedback. So I had a bit too much coffee, so I rewrote my library in Java one night, and I just code. Exact same suite tests. I used the Java functional library for the functional parts. And when I got up in the morning, the clean build was exactly the same time as the incremental build in SVT. I was just like, whoa, I wasn't expecting that. And the incremental wasn't really much different. It was about a 0.3 of a second difference with incremental. So it was so fast that there wasn't really, you weren't really shaving that much off incremental. And then, because I tried it with make. I was doing it with and tried it with make. And I shaved off 0.1 of a second. Didn't really seem like worth the hassle of make. If you like make and you know make, then obviously that's a good option to do. But for me, it was a bridge too far. I was kind of happy with I'm a bit old school. I was quite happy with and. So then I thought, no. Well, this is one off. So I tried a whole bunch of other Scala build tools as well. So I tried it with Maven. I tried it with Builder, and then I tried it with just classic ants. And what you see is SBT is the fastest incremental compile for Scala, for sure, but it's only as good as doing it in Java. Now, this isn't, I've had a few quirks with Scala anyway, so if you're using Scala and it's your best friend, I have no problem with your productivity boost that you've got there. I just want you to be aware of the compile time. And really, what I'm hoping that about this talk is that people will put pressure on the Scala compiler guys to actually sort because I'd quite like to come back to Scala if they could make the compiler a lot faster. It's just,
Can you try it with Tint? Maven with Tint too?
With which one?
Tint with Tint.
No.
It's an extracted part of SBT that runs.
Okay, that sounds good. Okay, I might. If you come and talk to me afterwards, I'd quite like to dig out one of my projects to see if I can get it. I just want more data. I want to know what's the fastest out there. So I did all of that, and I'm going to talk a little bit at the end because I've got something that I'm going to be showing you guys that I haven't shown anybody else at all. So I will. Actually, you know what? I've got it now. Actually, I'm going to show you. So, can everyone see that? Yeah. Okay. So I said I was a bit. Okay, so this is one of my libraries called Funkley. It's It's a functional templating library. This is an app build, you can see running, and it took 7 seconds. And because I thought there must be a way of going faster on these builds, and I've obviously got too much time, I've written my own compiler and build tool for Java. So now it looks very Antish, so I tried to copy Ant. Let's just do it. Okay. It's a single jar, and I'm building and testing the same. That's the same project, built and compiled in 3 seconds instead of 7. So this is a tool called JCompilo that I've just been working on. You guys are the first people I've ever shown it to. Do not go and start using it on your production projects. But the point is, I wanted to show you what could be done. So what am I doing here? I'm doing a few techniques. One is I compile directly into the zip file, into the jar. So normal Java C compiler compiles, does a whole bunch of disk scanning, lots of disk scanning, and then writes them into disk, and then you do some more copying, get all of your resources in there, and then you zip it up. That's a lot of disk I/O for no good reason, as far as I'm concerned. I came from the .NET world, so in .NET you just compile directly to a DLL, which is obviously a single disk write. So we get a big chunk of performance increase there just by compiling and jarring in one go. Also, the system by default, it actually, you can see down here, actually automatically ran all the tests in test classes in parallel, a bit like the Surefire plugin you can kind of configure. So the default is let's do multi-threaded, yeah, this basically, there's a few other techniques like I guarantee I only ever read a file once. So again, the normal Scala and Java C compilers, they rescan the disk all the time looking for stuff. So I preemptively, if you say you compile this directory, I just load the whole directory in a single disk read, which is obviously much more efficient for both your CPU and your architecture on your machine. So why am I showing this? Is really I just want to kind of give a hint at what could be done. So if there's anybody in the audience who contributes to any of the build tools out there, you should be looking at how much faster you can get. This I've actually made Java C itself about 20% faster. Yeah, just by getting in, so I'm extending it, I'm getting right into the interfaces of it and actually changing how it works. But really, I wanted to give the point about what you can do if you're kind of ruthless enough or maybe crazy enough, whichever you prefer. So basically, I haven't actually got the source code for this project, but it goes from, in my new build tool, goes from 6.7 seconds down to 4 seconds, and you just saw one now, went from 7 to 3. It's different depending on the project bringing it. Is the project disk-based or is it I/O bound? So you can have different behaviour that you're going to see. Enough. I hope no one took that as actually a Scala bashing. I'm hoping that Scala can get its compiler sorted. So one of the things that I often hear in enterprise organisations is we use Maven, and again, it's a fact. It's like the sacred cow. So I don't know if that actually means anything. So basically, it's a given. It's something that no one seems to be able to argue with. So my recommendation for you guys is to think of Maven as an output contract. And what I mean by that is you can work inside a Maven organisation where, or NuGet if you're in the .NET world, or Ruby Gems. You can work in those environments by producing an artifact that conforms to the standard without having to use the tool that produces the artifact. Does that make sense to everyone? So, I produce all of my tool now, I've written in pure Java, and one of the reasons I've written in pure Java is I have no XML. There's no XML passing my thing. I don't fork loads of JVMs. I use either custom class loaders, or if I have to, I fork a JVM. Some tools like JUnit basically prefer it, but I do everything, and then my build produces something that looks like it was built by Maven. So I can work inside my organisation who are completely Maven. We've got Maven artifactories and all of the infrastructure and tool support, and no one apart from my team know that I use any other tools. So we produce what is required. So it's a contract that you're doing, you're publishing to somebody. You say, I'm going to build something that's going to look like this. And really, it boils down to, it's very simple. It's just a URL. I mean, this is how this is what I did. So this is one of my libraries, Totally Lazy, and I publish this, and it's just a normal HTTP URL, and I can register this repo into a main project, you know, in a little config, or you can put it in your centralized repo repository. You can do, you know, similar things with like NuGet and Ruby Gems. They have extension mechanism where you can have a custom repository, so you can then just publish part of your build. You can publish somewhere, and somebody else can pick it up. And that's really the point of that, is to just have choice. So now you can choose, you know, whatever tool you like. Now, you know, the most important thing really is going to be it's a tool for your team. So if you just have one person on the team who's actually, you know what? The most important thing about building build tools is to have somebody on your team who's passionate about it. People say, "Oh, this tool is better than that," or that, blah, blah, blah. If you have somebody on your team who's like the champion for build tools, then probably the right build tool for your team is what that guy's a champion in. Like, you know, if the other guys in the team are like, "Oh, I don't really care, I'll run whatever command you tell me to run at the command line before I check in," then that's fine. So you should go with the passion. So, you know, don't go using my tool for sure. You know, I'm one guy. You know, use the tool that works for you, but you know, find the guy on the team who's really passionate about it. You need a crazy person like me who's just going, "I'm going to make it fast." All right, last one. So I said I kind of chucked out a few different things. So, you know, we chucked out GWT, we chucked out Hibernate, we chucked out our web container, and then this was, I think this was the final straw for most of the Mac lovers in my organisation. We're completely at my client. Every developer uses the nice massive 16-core, you know, 16 gig Mac Pro aluminium, you know, beautifully crafted machines. And when I got there, I was just like, this thing gets slow. I'm gonna install Windows on them, and they were like, what? And I installed Windows on them, and it was even slower. So Windows Disk I/O isn't very good. So we saw a 15% increase or slowdown, depending which way, from going Mac to Windows. And then I triple booted them and I put Linux on them. And then we saw a 15% increase go from Mac to Linux. And then, you know, most of the people were like, "Oh, no, you know, my productivity, I can't," you know. And I'm not saying you should all switch to Linux. But what I am saying is, if you're looking for speed, then, especially if you're thinking about this as your build server, so what operating system you build on. So obviously, you know, you're all going to build on whatever's most creative and comfortable for you as a developer, but there's lots of options there on your build server. So, you know, you could get, I mean, it ends up being at about, I think I measured it over, it's about 42% if you go from a Windows box to a Linux box for the builds that I've been testing on. So again, remember what I said at the beginning, don't listen to a word of what I say, measure it and find out. Most of our builds we found, we had either, you know, disk or network I/O, and they weren't just doing pure number crunching. If you're pure number crunching, you're probably not going to see any difference. Then the last one, SSD drives and your hard disk. So I have this ridiculously sized laptop, and it has multiple hard drives in it, and one of them is a stupidly expensive SSD drive that I bought going, I'm going to shave another 10% off my build time. And it didn't really make any difference in my builds. You know. So test it, verify it. I had one guy in the audience shout out to me, and he said, no, Dan, you're completely wrong. We use SSD drives, and we're a C and C++ project, and we went from an 8-hour build time to 1 hour just by using rated SSD drives. So it's obviously dependent on your environment. My builds and projects tend to be quite small because I keep on breaking them apart into smaller and smaller pieces, and that means that my operating system normally ends up caching all the files and loading them into memory. So measure it. We do use, at my client, we actually use RAM-based virtual machines. So the whole virtual machine is actually running off a RAM disk. So we've got a server box with 128 gig of RAM or something like that, and we actually run virtual machines. When an agent comes up, it's a completely, it's actually using a lightweight container, but it's running off a Rambus. So we do actually see some improvements in our build time there on those machines. And again, that was about getting faster feedback for the team. So we've got a shared build server amongst about 10 different teams. So it's really important that we get the build throughput through. I don't have exact numbers on that because that was actually done by the infrastructure team and not by myself. But the outside numbers I see are a build that takes about half an hour on my beast of a Mapbox, takes about 17 minutes. So there's still these legacy apps. I'm not telling you it's all perfect where I am. It's a long way from it, but we are converting them. And some of our slower builds, we've seen that kind of time decrease. And that's really it. I've shown you what I think is the future in the compiling and build tool area. Has anyone got any questions they'd like to ask me? Feel free to shout out. Or you can come up, if you're shy, you can come up and speak to me afterwards.
Everybody's astonished.
All right, well, for me, I think there's a lot more speed we can get out of our build tools. I think we're miles away from having these as fast. I mean, my goal, this is how crazy I am, my goal is to get every one of my open source projects to build to be sub 1 second, so that I can do continuous full build, not just incremental. I want to have a produced and tested jar with all of my test suite run in 1 second. Now, obviously I'm slightly waiting on my new 32-core machine to help me, because at the moment, so that's an 8-core machine, and I'm already, with my build tool, when you compare it to Ant, in Ant, you see the usage, it only uses 1 or 2 CPUs. I'm already maxing out all 8 of the cores by doing so much more stuff concurrently, because I actually run tests at the same time as packaging up for releasing source code and stuff like that. So there's a lot of parallel execution that I do. But I think there's a lot more we can do in shaving off time. And and the thing is that they very quickly build up to actually being quite an impressive amount of time being shaved off. So I just hope some of the other tools out there actually realise that a slow compile or a slow test is not a given. You don't have to just accept it. You can do something about it. So.
Did you look into possible existing tools that can help the speed up the build, probably something like JRebel or any other existing?
So one of the caveats I've always had has been on my build server, I'm always going to do a clean build. I don't trust any incremental technology whatsoever. I don't mind it at all for local builds, so I'm just doing a local build, and I want really fast feedback. I want that instant, so I'm just running it. I mean, one of the things here is that when you actually start moving out of using server containers and actually use like either in memory or some of the embedded ones, you don't even need JRebel. You can just press either if you've got continuous compile, it just works. You don't even need anything unless you remove a method in one of the unsupported bytecode operations. If you change a resource or a template, and you can configure, even with server API, you can actually configure it directly and say this is the web route, and not use a copied output directory, and you use the actual source directory, and then you can make edits directly in your IDE, and you will see them reflected immediately. So I really like what the JRebel guys have done, but I've yet to have a need for it where I haven't been able to do the simpler one and it worked okay. And where I probably really do want it is on the build server, where it's where I can do a full clean. So
the next question, it sounds like there is a one spot on the market. There is no such tool that can speed up the build from out of the box. Do you plan to just invest your experience in development of some kind of such tool?
Well, that's what I was hoping. I was hoping what I was demoing earlier was my new build tool and Java compiler. So that's written. I've written now. That's completely in Java. It's open source. It's called JCompiler. It's quite opinionated, so it doesn't follow the Maven directory structure. So it's much more like the old school. I'm a bit old school in my ways. So
actually, Scala team is looking for a guy who will be working on the compiler side. Don't you want to try?
Well, one of the reasons why I also ditched the Scala compiler was because I actually tried to apply a patch to it, and when I looked at the source code, I saw all these hard-coded file path directory structures and quite a few scary things in there. And I was going through the source code of the fast compiler for Scala, and it actually worried me that I was deploying production code. You could see that the compiler was quite immature compared to the Java compiler. It doesn't mean it's still like that. I mean, this is a couple of years ago now, but it needs to improve. But it's for me, I don't think it's enough of an important issue for other people. People just say, "Oh, but my productivity is so much better that it doesn't matter if I have to wait 10 minutes for my build." And I'm like, well, no, I think the productivity gain you get of when you have a 10-second build is, I can't measure this, but the difference you feel when you build. I mean, you probably all have had it when you started your project, and it's been a little tiny greenfield project, and you just everything is so easy, and then just slowly over time it becomes slower and slower. So for me, that's that productivity improvement of having a super fast feedback cannot be outweighed by. Actually, I think you should have both. It should be super fast build and brilliant language features. But I'm not prepared. I've spent quite a bit of time getting it super fast on my build. I'm not prepared to let go of that fast feedback. Just for a bit of syntactic sugar that I might be able to get in other ways. But that's me. But if it works for you, it's you keep doing it. Please.
Is it actually so reasonable to have such a great goal as 1 second for build? And don't you think that everything else around your build or other infrastructure can be not ready for it? It's like maybe the HTML page that will show you the result will take more long time to load than your build.
Yeah, I mean, I think one of the things for me is that in this process of looking at the build, it's not just the build. So if I can start and stop, so in one of my libraries, I use all of the different web containers that I talked about there. I bring them up programmatically and shut them all down, and I have a suite of 30 HTTP acceptance tests. So I'm testing the protocol specification, and I run those. So I've got 4 different implementations: Jetty, Simple Web, the embedded one, and the in-memory one. They're all running, and they're running a suite of the HTTP specification tests, and then I've got all the rest of the library tests, and the whole suite runs in 10 seconds. So I'm bringing up server, taking it down 30 times. So the point for me is, somebody asked me, "Oh, can you add into that suite Tomcat?" And I was like, I will if somebody can show me how to run Tomcat in embedded mode where it starts and stops quick enough. Otherwise, what we do is we actually just deploy to Tomcat to test Tomcat in a different way. But for me, it's feedback, and it helps me choose the right library. So talking about a web page response, when you start doing this, one of the problems is you actually start your app, and you say, "Oh, run the app," and then you sit there, and the app's already started. You didn't notice it start, because I don't know if you noticed, but on a web page, if a web page works too quickly, your eye doesn't think. If you don't see it happen, you click something, you don't see it. You don't think it's happened. So we've had that a number of times where I'll be sitting there with my team, and we go, "Let's start the app," and the app immediately goes in 1 millisecond. I've started, and it writes out a line in the syslog, and it says "started on this port," and we're sat there going, "Oh yeah, sorry, it has started already," and then we can just go to the web page, and the web page returns in, a couple of milliseconds. So once you eliminate all of those libraries and tools that just have, I think, unacceptable load-up times. Any library that has seconds to start up, it's like, what is it doing? you should be using, lazy initialization. It should be, either doing more sensible parsing. It's just our computers are so fast these days that any library that is taking, you can watch it starting is the wrong kind of library for me. Now, obviously, I have enterprise apps that are it's already a given, and they've been given to me, legacy ones. But we're slowly but surely eradicating the things. It's a long journey. I've been there, 2.5, 3 years, and I've been working through application and application to get done. And are they all done? No. And will they all get done? Who knows? I'm a contractor, so they'll probably kick me out with my crazy build time stuff. So I'm just it's got to work for you, and for me there's nothing sacrosanct. If it's too long, it's going. It's just a matter of time. We want to work out what the right thing to replace it with. So go on, one more.
Maybe I missed something one more time, but the stupid question. When we can get your tool, or how we can contribute to it?
So you can Google for it. They're all on. All my stuff I do is actually on Google Code. I've got about 15 open source projects, and they're doing all the things that we already do. I got one day one of the guys on my team just said, Dan, you need to stop complaining about these libraries you're using and write competitors to them that have those opinions that you've got in there. So, speed. I have none of my libraries are XML-based. They're all you do it in code, and that gives me such a massive speed boost. Like I have a DI tool, and the startup time for the DI tool is 0. It's basically it's a lazy type map. There's nothing to do. So one of the reasons all of these things are able to do is you just start eliminating things that are previously are given. So you can Google, you can search. There's a whole list you can see on my profile on Google Code. There's a bunch of stuff. I don't really want to be about my libraries. I want it to be about being ruthless and getting back your feedback loop. It's your feedback loop. Don't sit there like a frog getting cooked in a pan. That's it.